Hello, let's spin the cube. The cube is a simple and complex mathematical object. There are numerous ways we can play with it to develop mathematical insight. Indeed, the cube is one of those generative topics in mathematics which leads to all sorts of algebraic and geometrical ideas. One of my favorite projects is to spin the cube or rotate the cube around one of its long diagonals, which is also known as a main diagonal. A main diagonal is a diagonal, as you can see, connect two vertices from the opposite sides of a cube. And we have four of them, starting from any vertex of a cube. If we imagine or draw a line to the other side of the cube, we have a long diagonal. What would happen if we rotate the cube around one of the long diagonals? If you like, you can look around you to find a box, a shaping box or tissue box, which does not have to be a perfect cube. We are going to focus on the ideas. When we spin a cube around one of its long diagonals, we get a beautiful shape like this. At the two ends are two cones. In the middle, we have a surface, a ruled surface that's made up of straight lines, those straight edges of a rotating cube. And the middle part is called a hyperboloid, which is mathematically very rich. We can certainly create a 3D printable model and then print it as shown here. But for the moment, let's see how we can simulate the process of a spinning cube using GeoGebra. GeoGebra is an open source environment for mathematical explorations. You can go to geogebra.org to download it. There are many variants, or you can launch it directly from a browser. And it's a very user-friendly, teacher-friendly environment, and it's been there for 2 decades. Give it a try. I have installed GeoGebra on my computer, which is here. When you launch GeoGebra, you are going to see two windows. On your screen, things might be different depending on the version of GeoGebra you're using. I'm using the classic 5. So on the left, we have a algebra panel or window, perspective, whatever term you like. Here on the right, I have the 2D graphics window, the traditional Cartesian system, where you can plot points, graph functions. Let's go back to our cube. We need a cube, which is a 3-dimensional object. So GeoGebra does have a 3D graphics window, which can be launched from here. Go to View again. Your computer might be slightly different. View or Perspective, choose, click 3D graphics. Okay, there are many other options. Depending on your project, you may choose a different window. We need 3D graphics. Takes a short while for GeoGebra to launch. Get the 3D graphics window. You can adjust its size relative to the algebra and 2-dimensional graphics window. All right, so we now have a 3D Cartesian system We have the X, we have the Y, which is the green axis, we have the Z axis, which is the blue axis, and we can create three-dimensional objects in this window. For our purpose, we need a cube. Let's go to the menu system, and there are only a few options. Place your cursor on the tiny triangle, click it, see if you can find the tools you need. We need a cube, click it, and place your cursor on the icon for a very short prompt. Okay, in the beginning it might be confusing. Just slow down and you can go back and forth. You're not going to destroy anything. So to define a cube, we need 2 points or other corresponding objects. For our purpose, the orientation of the cube does not matter. We just need a cube. So we are going to select 2 points and allow GeoGebra to create a cube using its default parameters. Okay, let's go and select the origin as the first point and select another point on the x-axis to be a second point. Now we have a cube. Okay, you can use your mouse to change the perspective. Click and hold the right button. That's what I'm doing on a Windows machine. So we have a cube, and we are going to rotate this cube or spin the cube around one of its long diagonals. Next, we need to define a long diagonal or a main diagonal. We have 4 options. Either one is going to be fine. For our purpose, let's go to the menu system. We need a line. You can define a segment or array, whatever you like for your purpose. We do have a lot of options. So let's define a line connecting 2 vertices that are on opposite side of the cube. It's a line tool. We're going to select the 2 points, this point and that point. Either one's fine. Okay, one pair of vertices from the opposite side. So we're going to choose the origin. Why not? And that point. Okay, makes sense. It's called a G. You can zoom in and zoom out for a better view. All right, so we have our basic geometric objects and constructed or defined. Next, we are going to rotate the cube around this axis. All right. One thing, as you define things, objects in the 3D graphics window, its shadow is going to be shown in the 2D graphics window here. So this is a shadow of a cube, which is a square, right? And the corresponding algebraic names or entities are listed here in the algebra window. So the cube is called A. So the cube is named A. And by default, it shows the volume of the cube, which is 4 to the third 64 cubic units. And here we have a line. Okay, this line, the axis, that's a three-dimensional line, 3D line, which is different than the 2D line, right? Okay. If you're interested, look at the definition or the equation of a line in 3D space, which is very interesting. All right, let's spin it. How can we do that? Let's look to the menu system here. Okay. Right now I have I'm in the 2-dimensional graphics, so I'm going to click the 3D graphics. Okay. Click the window, so I'm working under this perspective. So now go back to the menu system and go back and forth, see if you can find the tool. It's a geometric transformation. Yeah, we do have one here. Rotate around line. Rotate, click this one, and again, place the cursor on the icon for a short prompt. Select object to rotate, and then the line, and enter the angle. All right, we know what we're going to rotate. We're going to click the cube, but it's pretty hard to click the cube because the cube has so many components here in the three-dimensional view. In this case, we could refer to the algebraic definition or representation. It's just A, right? So I'm going to click A, and if you make any mistake, and just go back and fix it. So I have selected the cube by clicking on its name. And next, I need to choose the axis. We are going to rotate this cube around what? Around this line. Again, you can, well, since this is a line, you can click it. Or alternatively, you can click the algebraic equation for the line. It makes no difference, right? This is the idea behind multiple representations. Either way, I'm going to click this line. And then we have a window there. So it's asking how many degrees do you want to rotate this cube around the axis, and counterclockwise or clockwise. And in our case, it makes no difference, right? So let's just choose 30 degrees. Okay, 45 by default, 30. Enter the amount of rotation. There we go. We have two cubes now. So this one in the algebra window is called A prime. Just another name. You can always redefine it, give it another name if you like. So this cube, for the purpose of discussion, you can always right click, change its color. Okay, you can change the color to, let's try green. You can also change its opacity, the line thickness if you want to. It's all up to you. Okay, whatever you prefer. Change the properties of these cubes or any object in GeoGebra. All right. Oh, you did not click OK. Let's try again. Right click, change the color, and change the opacity to 0. So we have a cube there. That's it. I can close this window. So the green cube, let me turn off the original one, is the original cube is a resulting cube after a 30-degree rotation. Right? So that's one of them. And using this idea, you can create numerous copies and see what it looks like. But there's another way to save time. We can use the idea of a slider or a parameter in GeoGebra. Let's do that. Okay. Let's keep our green cube there, and I'm just going to turn it off. Hide it. Okay. By clicking these radio buttons, you can change the visibility of an object. So I'm going to define a. I'm going to go to the algebra window. Define a parameter. You can call it a variable. So amount of rotation. Amount of rotation. Give it an initial value, say 30 degrees, and look at, click this alpha for the unit, the degrees symbol, 30 degrees, right? Press enter. So now we have defined a parameter and amount of rotation. We are going to use this to control the amount of rotation for the command that rotates the cube. So in GeoGebra, this can be visualized as a slider. You can just turn it on. So now we have a slider, and you can change its color, change its length, and we're not going to do that right now. So by dragging the slider, you can change the amount of rotation. Make sense? So now, by default, it goes from 0 to 360. I can make it thicker so you can see it, right? Change the property of a slider, that's it. Length, speed, line, opacity. Make it really dark, yep. Change the color to How about red? Whatever color you like. That's the slider. That's the point. Color of the slider, and make it red. Okay, right. And you can also change the minimum and the maximum of this the parameter or slider. All right. Next, we are going to use this slider to control the amount of rotation. Right, let's go back and do the rotation command again. Rotate around line. I'm not in the 3D graphics view. I'm going to click the 3D graphics view, just make sure I'm working there. All right, make sure you're doing that. Rotate around line. Rotate what? The cube. Go back and use the algebraic definition. Right, that's A, the original cube. We are going to rotate it around this axis. When you are asked to enter the amount of rotation in terms of angle, just type the command you have there, the variable, amount of rotation. Okay, we're just using the phrase amount of rotation. Clockwise, counterclockwise, it doesn't matter. Amount of rotation, okay, it's case sensitive. Just anytime you make a mistake, you can go back and change it. All right, now we have a prime sub 1 created, and this is the rotated cube. How many degrees? 242 degrees. Let's change the color so you can see the difference. Change it to how about blue? Okay, blue. And you can change its opacity if you want to. Doesn't matter. All right. So the A is the original cube. We can turn it off now if you want to. Okay. And blue is the rotated, the resulting cube. Now, since we have a variable, I really want to use the term parameter. Anyway, that controls the amount of rotation. We can drag the slider or animate it. And see, the red one is the original cube. It's being rotated 12 degrees, 20 something, 30, 40, 50. As it rotates around the axis, a shape is created in space. What is that shape? Well, in GeoGebra, we can actually turn on the tracing feature so that we can get some visual clue about what's going on. It's a simulation. So you can right click on the blue cube. I'm using the algebra window here. It's just easier. Right click and choose or activate. Trace on. Okay, we are going to make a lot of traces of this cube. Trace on. Now go back and drag the slider. See what happens. That's what we get. Okay. It's very smooth. It's a very good looking three-dimensional shape. Okay. And you can go to view and do a refresh views, or Control F on Windows to remove the traces. So now we are back to the beginning. Well, yeah. Well, the blue one is now the consequence of rotating the original cube 360 degrees. Of course, it goes back to the original. You can go back. That's the idea. All right. So right now, since I think the slider goes up by 1 degrees. Let's see. Yeah, 1 degrees. You can try. How about 20 degrees? Right. So every 20 degrees, we make a trace. So we're going to have 18 of them. See what happens. 18. You can try 15 if you want to. Just by changing the increment, you can play with the shape. Okay. All right, let's go back and drag this slider. All right, so the slider goes up by 0, 20, 40, 60. Right, so we have a 3D shape like that. Make sense? This is a simulation. This is a visual representation of a rotating cube. It's not 3D printable. You cannot save this and print it. To make a 3D printable shape like this, and we would need a 3D design environment, like OpenSCAD or Autodesk Inventor or Fusion 360 or any other 3D design software. All right, you can play with it in your own way, and that's the idea of spinning a cube in GeoGebra. The challenge right now is, hey, can we develop a algebraic equation for the cones, okay, at the top and the bottom, and also for the hyperboloid in the middle. That's a very interesting secondary math problem. All right, this is what we have. Spinning the cube using GeoGebra. Thank you for watching.